Okay, there's lots of ways of defining acids and bases. In a first-year chemistry course, oftentimes the Arrhenius definition is focused on, where an Arrhenius acid is anything that has H+. The other component of water is simply a base, OH-. That's a nice simple way of looking at acids and bases. I like especially the fact that just because you contain H+, like say acetic acid, doesn't mean it's an acid, not until it goes into solution and the H+ is actually there when it ionizes. A more all-encompassing definition of the Bronsted acids and bases, where we define an acid in the Bronsted sense as something that has donated a proton, right? And we define a Bronsted base as something that has accepted a proton. What is a proton? In case you're wondering, it's H+. Let's take just a second to make sure that makes sense to us. H+ is a proton? Why do they say that? Well, what's in H+? Do we have protons? Yes, 1 per ion. Do we have electrons? Well, we did until it turned into H+, and then it doesn't, so no, there's no electrons. Do we have anything else? Do we have any neutrons? Well, for that you have to think about isotopes. The most abundant isotope of hydrogen is known as protium. It's over 99.7% of the hydrogen atoms or ions. And they have no neutrons at all. And so to greater than 99% approximation, H+ is in fact a proton. Okay, let's go back to this little example. If you take ammonia and you throw it in water, it'll make ammonium hydroxide. It's more precise to say that it will make the ammonium cation and the hydroxide anion, since that solution is completely dissociated. So NH3, what's it doing? It turned into NH4+. It accepted a proton, therefore it acted as a Bronsted base. Water has both acid and base in it, but in this particular case, the water lost H+. It donated its proton. It's acting as a Bronsted acid. And what did it form? It formed NH4+, which is actually weakly acidic, and it formed OH-, which is strongly basic. We always call these two products the conjugate acid and the conjugate base, respectively. So that's what happens. Acid and a base forms the conjugate acid and the conjugate base. If you get those confused, sometimes you can say to yourself Ca+, Cb-, because the acid always becomes one more positive, the base always becomes one more negative. Now I say becomes one more positive because it does. It gains a positive charge. But be careful. If you were -2, you'd go to -1. So when you say Ca+, that's just a little reminder. It doesn't mean it's always plus. It becomes one more plus. So that's acids and bases and their conjugates.